So today we're working with volumes of cones. Now a cone is very similar to a cylinder in that its base is a circle, but the difference between a cone and cylinder is across from that circular base is a little apex. So it comes to a point instead of being flat like a cylinder does. Where a cylinder, when you have the base, across from it is the exact same shape. That circle is exactly the same top and bottom. Okay? A cone comes to a point. All right? Now, it's helpful to think about cylinders when working with volumes of cones because there's a relationship here. Okay? Just like a cylinder, a cone always has a radius, which is the distance from the center to the edge of that circular base. And it also has a height, the distance from the base to the very apex. All right? Now, if I have a cone and cylinder with the exact same radius and the exact same height, it turns out the cone's volume is a third of the cylinder's. In other words, take the volume of the cylinder divided by 3, and that'll get you the volume of a cone with the exact same dimensions. Okay? And the reason why that's helpful is because that's one less formula we really have to memorize. Because we know the volume of a cylinder. It's the area of the base times the height. And in the cylinder's case, that base is a circle, so it's pi r squared. So the cylinder formula is pi r squared times height. And since the cone is just a third of that, we take this formula and stick on a divide by 3 at the end. So there is our cone volume. So it's the area of the base, the circle, pi r squared, times the height. And then because it's a cone, we divide it by 3. Okay? So let's see some examples so you can see it in action here. All right. So we've got a cone here. Notice our radius is 6. Here I'll label it R. Our height is 25. And if I want my volume, we do the area of the base, pi times the radius squared. And we multiply it by the height, 25. And if this was a cylinder, we'd be done. But it's not. It's a cone. So we also have to divide by 3. Okay? So let's do this on our calculator. We do have pi here, so I'm going to give my answer in 2 forms. First, I'm going to do the exact form. So I'm going to multiply and do all the work in my calculator except for that pi. I'm going to leave the pi out. 6 squared times 25 divided by 3. So I get 300. So what I'm going to do is write down 300. I did not put pi in the calculator because I'm going to stick pi next to my answer here. So my volume is 300 pi centimeters cubed. And that's my exact answer in terms of pi. Meaning, whatever 300 times pi is will give me my exact volume. All right, I didn't have to round anything. I didn't have to approximate anything. I know whatever this comes out to will be exactly the volume. However, a lot of times we need the approximate one too. So to get the approximate, we'll just do 300 times pi on the calculator and round the answer. And see how there's a decimal there? Because pi is irrational. So we're going to have to round this. It comes out to about 942.5 centimeters cubed. And because we rounded it, that's our approximate answer. Hopefully you see the difference between those two. One has pi still in it, and we didn't have to round it at all. One, we put pi in the calculator, and we did have to round it. Okay? So let's do 2 more examples, but this time the opposite. And this is where things get a little harder. Okay? I'm going to give you the volume, and we're going to find a missing dimension. Okay? So for the first one, the volume of a cone is 150 pi centimeters cubed. If the height is 18 centimeters, what's its radius? All right, let's set this thing up using the volume formula. The volume of a cone we know is pi times the radius squared. In this case, we don't know the radius, so it's x squared, times the height, 18, divided by 3. I know, it's a lot. Okay? Pi times radius squared times height, divided by 3. And that should equal our volume, which is 150 pi. Okay? So there's our equation. And that's the equation we're going to have to solve in order to figure out what that radius is. Okay? Now, luckily, our volume is in terms of pi, which is actually going to make things a little bit easier. But let's simplify this a little bit, all right? Because I know 18 divided by 3 right away is 6. So let's just make this pi times x squared times 6 equals 150 pi. Okay? Now, let's start undoing things. I'm going to divide both sides by pi. Okay? And when I do that, the pi's undo each other over here. I get x squared times 6 equals. Now on the other side, because there's a pi there, that also undoes it. And I'm left with 150. See, having that volume in terms of pi really makes math a lot easier. All right, we're a couple steps away here. We've got to times 6, so we've got to undo that next. So I'm going to divide both sides by 6. I end up getting x squared equals, well, whatever that is, 150 divided by 6, 25. All right, we're almost done. We've got x squared equals something. We still need x. So to undo x squared, I'm going to square root both sides. And when I do that, squaring and square rooting undo each other. X equals, the square root of 25 is 5. And the units are centimeters. So the radius must be 5 centimeters. Okay? So notice, just set up an algebra equation and then simplified it and then just started solving it. And like I said before, the volume is in terms of pi, so it was a lot easier and cleaner to work with. Notice I didn't have to do anything with decimals at all. That will not be the case on my next example though, because what if the volume is not in terms of pi? How will that change the problem? Well, you're about to find out, because my third example, the volume is not in terms of pi. So check it out here. It says, the volume of a cone is 2,000 centimeters cubed. All right, so notice, not 2,000 pi, 2,000. If the radius is 11 centimeters, what is its height? Okay, so let's set up an equation just like we did last time. So volume formula of a cone, pi, times the radius squared, in this case 11 squared, times the height, which we don't know, so I'll call it x, and then divide by 3 because it's a cone. All right? And that's going to equal my volume, which is 2,000. All right. So at first this doesn't look too bad, but it's going to get messy real quick. So prepare yourself. Here we go. All right. Let's simplify this 11 squared. I know 11 squared is 121. That's just going to make things a little easier later. I'm just going to rewrite everything else. All right, so let's start undoing this piece by piece, okay? The first thing we did last time was divide by pi. So we can do that here again. Divide by pi. Pi's undo each other. I get 121 times x divided by 3 on this side. And then 2,000 divided by pi. There's no pi to cancel out, so I'm actually going to have to do it on my calculator. Boom. And look at what I have. Quite a big mess. I'm going to round this to 636.6. All right. Now, even though I rounded this and I wrote it on my paper, I'm not actually going to use this number when I solve it for the next step. I'm actually going to use this number on my calculator window. So I'm not going to clear this. I'm going to use that. So keep that there. All right, let's go through my next step. We have some choices here. We could divide by 3. We could undo the divide by 3 or undo the multiply by 121. Let's undo this divide by 3. So I'm going to multiply by 3 on this side. But what I do to one side, I have to do to the other. So here we go. Multiplying and dividing by 3 undo each other. I get 121 times x equals, and instead of just multiplying 636.6 by 3, because that was rounded, I'm going to take this answer and multiply it by 3. So I'm going to use my previous answer, and that's what the ANS stands for, the previous answer, because my calculator knows that whole long decimal. And I'm going to multiply that whole thing by 3. All right, and see what I get? I still get another crazy decimal, 1909 point, let's call that 0.9. All right, but I'm being more precise with my answers because I'm using the exact numbers that the calculator found before. I'm not rounding it each step of the way. Okay? So now, last step. It says times 121, so I'm going to divide by 121 on both sides. And those undo each other. X gets me, and by the way, I should be putting approximately because I did have to round these on my paper, but all right. So I'm going to take that previous answer, this window, this number on my window, and divide it by 121. So take the previous answer, divide it by 121, boom. Again, it's still a crazy decimal, but we're going to round it because this is our final answer. We'll go 15.8 centimeters. All right, so the height of that cylinder is about 15.8 centimeters. Okay, so again, it's a little bit messier because that volume is not in terms of pi. And when we divide it by pi, we know we're going to get some crazy irrational number, which we'll deal with, but the calculator did all the hard work for us, so it's not such a big deal. Okay, but just work step by step and work carefully. Okay, and on the cones, don't forget about that divide by 3. That's a very common mistake that people make. All right, so hopefully you found this video helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But with that being said, good luck on your math, and I will see you next time.